uh, NQT exam. So I just did some kind of research, as you all of you do on the Google, and I went to various sites to see what is the pattern of the exam. And all of you are aware about the pattern of the exam, that there will be two coding questions. So along with uh, so if you talk absolutely about the coding part, okay, so coding part of NQT. So there will be, as of you, all of you know, there will be two questions, right? Where you have to do the hands-on coding, and out of that, the one question will be easy, okay, and the second question, and there will be another question which will be of medium level, right? And I hope all of you have given the mock test. So how many of you given the mock test which is there on the TCS IN? Can you tell me in the chat box? Right, there is this mock test given by the TCS NQT on the TCS IN. So how many of you have given that? Have you solved the coding questions there? Okay, so you can put your answers in the chat box if you have given. Yet to give, you are not given the mock test yet. Okay, so give the mock test, and there so yesterday I visited that site, and I have solved the problems which are there on the coding part, and that I will discuss in today's session. Okay, so whatever information I'm going to give to you, this is compiled from the various sources which are there on the net. So type of coding questions. So as I've told, that there will be two questions, one easy, one medium level, and the total time to solve all of them is 1 hour. So you can say that the time is more or less less to complete all the two questions completely. For this purpose, you need to have all the code snippets ready. Okay, so you need to have all the code snippets ready with you, because the time is very less. And if you have all these things ready with you, then you may try to break, or if you try to you can complete all these two questions in time. Okay, so which coding snippets I'm talking here? I'm talking about the coding snippets which are there, which related to all these problems. For example, reversing a string, okay, reverse a number, prime number. So many a times there will be series questions, okay, where you have to generate the nth number of a prime numbers. Okay, so for example, greatest of 10 numbers, Fibonacci series, HCF and GCD related. So I think all of you have gone through all these things. Okay, so all these are the very basic questions, but you must have the complete understanding how to solve these questions with the twisted format also. Okay, so they will not give the straightforward statements to you to solve. So there will be some kind of trick will be there, but still the essence will be the same, and you need to have those skills so that you can modify the given code for your own purpose. Okay, so this is what type of questions I have got. So yesterday I visited the mock test of the TCS, and there I found this first problem, which was the easy problem. And here, this is the problem statement which was given. Okay. So before moving on, is my screen visible? Is presentation visible to you completely? Okay, so that there will not be any problem. Okay, so now in this case, you can see this is an easy level problem which they have given on their platform. So they have basically given a below series. Okay, so 1 2 1 3 and so on. Okay, it continues, and this is a series mixture of two series, all the odd terms. Okay, so this one, this one, this one, so all the odd terms in this series are from the Fibonacci series, and all the even terms are the prime numbers in ascending order. Okay, and what you have been told to write a program to find the nth term of this series. Okay, so they may give you the n equal to 14. Okay, so in that case you should print what is that particular number from that series. Yes, it's a combination of two series. First is odd number. So odd index terms are belong to the Fibonacci series, and even terms belong to the prime numbers in ascending order. Okay. So in this case, the value of n is a positive number, and that should be read from the standard input. The nth term is calculated by the program and should be written to the std out. That is, you have to print that. And other than the value of nth term, no other character, string, and message should be written to std out. You just have to print that what will be that nth term of this series, right? And for example, they have given one example. So n equal to 14. The 14 term in the series is 17. So that 17 should be printed. So you can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14th number of this series is 17. So that 17 should be printed as output, right? So basically what you need to know, you should be able to write a program, okay, so that given n, you should find out that particular element of a Fibonacci series. So you have to deal with two problems here, sub problems. Basically, you have to write a program to get nth number of a Fibonacci series. Then you have to write another program where, given the value of n, you need to find out the prime number for at that particular position. So these two programs you need to write. So all these things should be ready with you, right? So if you want to do the hands-on for this particular case, okay, so let me just so so what I've been given in this case, you have given the series as 1, 2, 1, 3, 2, 5, 3, and so on. Okay, so I will just keep this and so on. So this is the index 1, so odd index. So this is 1, 2, 3, 4. This is your n, capital N, right? 6, 7, and so on. Now in this case, this odd number terms, so these odd number terms, they belong to what? They belong to these are the Fibonacci, right? All of you know. So series 1 in this case is Fibonacci, right? And series 2 in this case is prime numbers in ascending. So here you can see that the even number terms, right? So 2, 3, 5. Now here it will be 7 and so on, right? So the second series in this case is a prime number in ascending, and this is 2. So they have given you n equal to 14, right? So n equal to 14, you know that this is even, and two series are there. So if n is equal to even, right, that is 14 in this case, then this belongs to the, if you count that, this belong to series. So if n is equal to even 14, right? So in this case, this will belong to the series 2, right? So if capital N, which is input, so one thing you can say here, if n is even, then in that case, the output belongs to series 2, which is prime numbers in ascending order. And if your capital N, which is input from the user, is odd, right? If it is odd, then it will belong to this first series, which is a Fibonacci series. So basically, you have to find out that, right? So how you can proceed in this case. So first of all, I will write down the programs related to that. First for the Fibonacci and second for the second series, right? So in this case, so I will define my series 1 first, where I will take input as n. N is equal to 0, you know that it's a invalid input for this case. First series we are going to write down for the Fibonacci, right? Then n equal to 1, then in that case what we have to do, we have to return 1, because our Fibonacci series in this case is starting from the 1. So 1 1 2 3 and so on. Then if n is equal to 2 in this case, then also we have to return 1. And else what we can write, we can use the recursion here and we can return so we have first defined the first two members of our series, n minus 2, right? So this completes our program for the series 1, right? So once you have defined the series 1, what you can do, then you can write the program for your series 2, which is getting the nth prime number in ascending order, right? So series 2, here also the argument will be n, and in this case how can you do, we know that our prime list starts from, I will define one list in this case. So prime list I will define, we know that the first prime number is 2, and then so the first prime number that we need to test is 3, right? So we will start from the 3 here. Then we are going to create our prime number list. So then we are going to check if the number is divisible by any prime number before it. Okay, so for that purpose, we are going to write for list. Okay, and in this case, if any number modulo p is equal to 0, that is, it is divisible by the previous prime number which is available in our prime list, then we know that immediately that it's not a prime number, so we can break out of that, right? And else what we can write, else we can write that this is the prime number, so we can add that to our list. So prime list dot append, and here we can take our number as a, add our number in the prime list. Okay, and after that what we can do, we know that even numbers are not at all the prime numbers. So one thing we can do here in this case is that and add our, increase our number which we initialize with the 3, so num plus equal to 2, right? Because we don't need to check for the even numbers, so even numbers are always divisible by 2, so we can skip them. And then after this is over, we can return our prime list. Okay, so we want the last number, right, which is our nth number, so return we know that how can you access the last number of your list? You can always put a -1 there, right? So -1, so list of -1 will return the end element, which is our nth element, right? So because we are only interested in the nth part of that, okay? So prime list of -1, in this case, will return the last element of our list, which is a, so basically what we have done, we have generated a prime list up to n, and we have accessed the last element, right? Then we will write our main function. We just have to now take the input n from the user side, and then appropriately, whether it is a even number or odd number, that capital N, we have to generate a particular element from that series 1, either series 1 or either series 2, and that we have to print. Okay, so here I can write the define the main method. So now here I'm taking the input n from the user. So you know that you can use the method as input, and I'm going to convert it into integer. Now first I just have to check whether it is even or odd, right? So if n modulo 2 is equal to 0, right? Means it's, if it's even number, then output from series 2, right? So the output from series 2, right, which is our prime numbers in ascending order, right? So in that case, what you can write, so I can write just print, and in this case we have to half the value of n. So in this case we have to write print series 2, and in this case we can write n integer division by 2, right? Else our output will be from series 1. Our Fibonacci, right? And in this case we can print series 1 now, and in this case you have to write +1 in this case. Okay. So this is our program. Python. So I have to provide the input in this case. Let's just give the 14 as they have given. minute. Let me just debug what is the problem. Just a minute. Just a minute. I will just debug what is the problem. I think it's because of the so so I already created a document, so I'll just copy from there. Formatting is not coming. Okay, I will share this PDF with you later on, but if you run this, you will get the answer as expected. Okay, so nothing very tricky in this case. You just have to deal with the two series, and accordingly you have to just take a n from the user and then you have to print it. Okay, then the second part, okay, the second problem in this case was the advanced coding, and in this case what was the problem? Activate another Honda environment and then let me check here. This is the problem of a formatting. Okay, the second problem of this mock test was the advanced coding problem, and it was a spiral problem. Okay, and in this case, you can see the problem statement in this case. So the second problem was the numbers of the Fibonacci sequence 0, 1, 1. So sequence is the given Fibonacci sequence, and these are written in a spiral from starting from location 0, 0 and moving as shown in diagram below. So here you can see the first number. So here these are the coordinates. In this case you can see 0, this is your y coordinate, this is your x coordinate, arranged in this manner, and this is going to get continued. Okay, this is just for the demonstration purpose they have given, and in this case you can see that this is also called as the Ulam's spiral problem. You can Google, or you can see its help from the Wikipedia also. Okay, actually this problem was originally designed for the natural number or prime number, but I think this TCS people, they have modified slightly for the Fibonacci sequence. So instead of prime number, they have taken the Fibonacci sequence in this case. And here you can see the first element of a Fibonacci sequence is at the location 0, 0. So x is 0, y is 0. Then the second number is at 1, 0. So x is 1 and y is 0. And they have arranged in this manner. So this is your first element, second element, third, fourth, fifth, and so on. So these numbers will be arranged in this spiral form. And what they are asking in this case, so for example, the 1, 2, 3, 4, fifth. So fifth element of this. So they are going to ask you, what is the coordinates for the fifth element of this sequence? So in this case, you have to count the fifth element. You have to first of all find out the fifth element, so which is 1, 2, 3, 4, fifth, which is 3 in this case. So you can locate 3 in this case, and you know that the coordinates for these 3 are nothing but -1, 1, right? So this -1, 1 you have to print. Okay? And here they have mentioned the objective. So the objective in this case is to find the position, which are nothing but the x and y coordinate of a given prime number. Okay. Actually, yesterday I solved this problem yesterday in the class, and then I made this PDF. So in order to save the time, I copied directly, but still this is not able to. Let's try this problem in whether the formatting is no. Still there is no formatting. So it's okay. This first problem I will share the PDF. Then you can later on take a look at it. Okay, and so here you can see the input in this case consists of multiple lines, and the first line gives the number of test cases, which is capital N. And for each test case, there will be n lines, and for each line, they are going to give you the any nth number from this Fibonacci sequence, and for that you have to print the coordinates. Okay. So the output in this case will consist of n lines, and each line consists of a space separated pair of integers giving x and y coordinate of the corresponding Fibonacci number in the input. Okay. And the constraint they have given that number of test cases will be less than 20, less than or equal to 20, and the each Fibonacci number can lie between this huge number. Okay. So this is they have given. So one example is given here. So two test cases will be there, and third and fifth you have to find. Okay. So you have to find the you have to print the coordinates for the Fibonacci number 3 and Fibonacci number 5, right? So here you can see. So for 3, you know that it is equal to -1, 1, right? And 5, it is nothing but -1, 0, right? So the same thing you can see, -1, 0 here for 5, and for 3 it is -1, 1. So basically, the first input will be your number of test cases, which are 2 in this case. The second is the Fibonacci number from that series. Okay, and the second number is also Fibonacci number from that series, and for that particular Fibonacci number you have to print the coordinates. Okay, so you can see the explanation. There are 2 Fibonacci numbers in this test case, and they are 3 and 5, and the coordinates based on the spiral form are -1, 1 and this one. Another example, so 3 test cases will be there, 5, 8 and 13. These are the numbers from this Fibonacci series, and for that you have to print the coordinates. So for 5 it is -1, 0, -1, 1 for this 8, and for 13 this is 0, -1, right? So how can you solve this problem? So basically, when I searched the solution, actually I tried first of all, but was not able to understand it completely. But then I find a similar question on Geeks on Geeks. Okay, and this is already solved there, so you can go and take a look at it. Right, so this is similar problem. Okay, the only difference here is that the instead of Fibonacci sequence, there is a prime number sequence. Okay, and here you can see, I will just explain what I understood from here. So you can see that the difficult level is medium in this case for this problem. And okay, so this is basically a Ulam spiral. Okay, so basically Ulam, one scientist, he arranged all the natural numbers, okay, in this spiral form, and he got to know some kind of pattern there. Okay, he arranged the prime numbers, and he got to know that when he arranged these natural numbers on this spiral form, he got to know that these prime numbers in this case, they usually form some kind of a pattern. Okay, so this is the problem. And in this case, you can see that it is same as earlier. The only difference is that here the prime numbers are arranged. So 2, 3, 5, 7, and so on. Okay. Now, how to solve this problem? So in this case, this is kind of easy. So basically, you have to find out the generalization in this case. Okay. So how you can do that? So I will just explain how you can solve this, the logic behind solving this problem. So let us start from this point. and so on. Okay, so this will extend. So in this case, this is a prime number 2. Okay, so in our given problem, this is Fibonacci number. Okay, so it will start from 0 and so on. So this will be 2, this will be 3, 5, 7, then 11, then 13, then 17, 19, 23, 29, and so on, right? So you can, this is how you can traverse and you can arrange those numbers, right? And in this case, basically you can give the values of the coordinates, right? So in this case, this is nothing but your 0, this is 1, this is 2, this is -1, this is -2, right, on y-axis. And on this side, this is 0, this is 1, this is 2, this is 3, -1 and -2, right? So once you get to know that, you got the spiral form, and in this spiral form you arranged your prime numbers, right? So I will just explain for the prime number, then you can immediately generalize it for the Fibonacci also. Okay, now in this case, once you have got this, first of all you have to find out the pattern. Okay, you know that for the first element of your prime number series, that is 2, the coordinates will be 0, 0, right? Then you go here, then you then here also you note down what is the x, where the coordinate is changing, whether x is increasing or whether y is increasing. That pattern you have to find out. So for that purpose, we'll create one table. Okay, so for example, we'll write our prime number here. Okay, and in this second column we will write our step number. Okay, so we'll go step by step. So this is our step number, which is k. Then in the next column we are going to note down our capital X and our capital Y, and then in this next column we'll just write down the observations or the remarks regarding X and Y coordinates. Okay, so for the prime number 2, that is our prime number 2, so this will be our step 1. Okay, and in this case we know that X and Y values will be 0, 0, because this is the first element, and there is no need to remark in this case, right? Then in the next case, the next prime number is 3 in this case, right, which will be our step number 2 that we are going to proceed out. So for given each prime number, so as I mentioned, there will be n test cases. For each test case there will be one line, and for each on one line you are going to get one prime number, right? And for that prime number you have to print the what is the coordinates for that particular prime number, right? So you are going to go step by step in this case. So step 2, we are going to write down the coordinates for 3, and for 3 you know that in this case this is X is 1, Y is 0, and in this case you see that based on the previous one for 2, now in this case you can see the X is increasing by 1, so the remark in this case is X increased by 1 in this case, right? Then for prime number, next prime number, that is 5, right, which will be our step number 3 in this case, right? Now in this case for 5, we know that what are the coordinates for 5? X is 1, Y is 1, right? So this is X is 1, Y is 1, and in this case we know that based as compared to the previous prime number, in this case Y is increased, X is constant, right? Y is increased by 1, right? Then for prime number 7, right, which will be our step number 4, and in this case the coordinates in this case will be for 7, this will be 0, 1, right? This will be 0, 1. Now in this case you can see that compared to the previous one, the X is decreased by 1, right? So in this case X is decreased by 1. Then for next prime number, which is 11, sorry, the next prime number which is 11, which will be our step number 5, and for this case For 11, the coordinates are minus 1 on the x-axis and 1 for the y-axis. So minus 1 comma 1. Minus 1 comma 1. And in this case, you can see that again in this case, x is decreased by 1. X is decreased by 1. Similarly, for 13, which is step number 6, the coordinates are minus 1 comma 0. And in this case, y is now decreased. Now x is constant, right? X is constant. Now in this case, y is decreased by 1. Right? So if you create a table in this case, you will get to know one pattern in this case. Okay. So the pattern in this case is that this is one group. Okay. Then this is another group. Then this is third group. Okay. So you get to know some kind of a batches here. Okay. And for that particular batches, for in this case, for example, this is your batch number 2. Okay. And in this case, you can see that for half iteration, the x is increased by 1. And for the second part, y is increased by 1. Now in this case, what will happen in this case? For the next, that is 17. Okay. So batch number 3, you will also have this 17. And in this case, this will be step number 7. And in this case, for 17, this will be minus 1 comma minus 1. So again, y is decreased by 1 in this case. Okay. So this batch number 3, there are 4 combinations. So you can see that for batch number 2, there were 2 rows in this case. Okay, where x is increased by 1 and then y is increased by 1. For the third batch, however, there will be 4. So here you can see that batch limit is increasing by 4. Okay, you can see the pattern. You can create a table at home and you will see the pattern in this case, which is emerging. Now in this case, you can see that for the half of this case, the x is decreasing by 1, and then in the second case, y is decreasing by 1. Okay, so after that, you can get to know one pattern in this case. Okay, so you will get such kind of pattern. Okay, and this pattern is shown here. Now in this case, you can see that they have created a batches. Okay, batch A, batch B, batch C. So batch is nothing but batch A का मतलब कुछ नहीं है, it is related to x. Batch B मतलब it is related to y. Okay, then numbers they have given. So this will be your first step, and in the operation in this case is plus 0. Okay, means what, you are not going to do anything. So because for step number 1, which is your prime number 2, and for that case, you know that the coordinates are x equal to 0 and y equal to 0. So no operation is to be performed in this case. For the step number 2 and step number 3, in this case, x and y are involved, and in this case, you are going to increase its value by 1. So that is why the operation shown here is plus 1, right? Then for the second batch, right, now there will be 4 steps in this case. In the previous batch, there were 2 steps. Now the number of steps in this case are increased by 2 for the next batch. So instead of 2, now there will be 4. So 4, 5, 6, 7 for steps 4, 5, 6, 7. Half of them will correspond to x, half of them will correspond to y, and the operation that will be performed in this case is minus 1. Okay. Then for the third batch, again, now there will be, यहाँ पे 4 थे तो यहाँ पे कितने होंगे, अभी 2 से इंक्रीज हो जाएगा तो यहाँ पे 6 होंगे, राइट? सो 8, 9, 10, 11, 12, 13, तो यहाँ पे 6 मिलेंगे आपको, और ये 6 में से 3 will correspond to x and half of them will correspond to y, and the operation that will be performed here is increase the value of the y x coordinate by 1 for these steps, and for the 11, 12 and 13, the coordinate y will be increased by 1. Okay. Then for next batch, that is for step number 14, 15, 16, 17, 18, 19. So now in this case, यहाँ पे 6 थे तो यहाँ पे कितने होंगे, 8 होंगे, राइट? और ये 8 में से जो 4 होंगे उसमें से x आपका -1 हो जाएगा, और नेक्स्ट 4 में आपका y कोऑर्डिनेट 1 से कम हो जाएगा. तो एक पैटर्न ये आप ऑपरेशन में भी देख सकते हो कि अगर पहले प्लस ऑपरेशन था, +1 था, तो नेक्स्ट इट इज -1. यू कैन सी दे आर अल्टरनेटिंग ईच अदर. तो ये पहला तो भूल जाओ, बाद में जो आपका सेकंड है +1 है, बाद में ऑपरेशन -1 हो रहा है. सो द ऑपरेशंस आर स्विचिंग फॉर ईच बैच. तो अगर एक बैच के लिए अगर +1 है तो नेक्स्ट बैच के लिए -1 होगा, नेक्स्ट बैच के लिए, तो प्रीवियस बैच के लिए अगर -1 है तो अगेन +1 होगा, एंड सो ऑन. ओके, so this is the pattern which is emerging. Okay, and based on that, so how you can solve this problem now? So given a So how you can approach this problem? So first of all, for a given prime number, okay, for example, let's say it is 19. Okay, the prime number is 19, let's say, which is your input. Find out the step number. Okay, you will find out the what will be the step number for that particular prime number based on our table. Okay, so that step number in this case is k is equals to, in this case, is equal to 8. Okay, so the k in this case is 8. Okay, and for that, once you get the step number, okay, once you get the step number, you can find out the coordinates to be 0 and -1. Okay, so this is what you can approach. Now in this case, you can see that if you see the given solution in this case, so this is another block diagram which shows how you can solve the problem. So basically you are going to create a prime number generator. Okay, so any number you have to generate, your program should generate any prime number, nth number prime number, and then this input you are going to give to the spiral coordinate finder. So given a prime number, you need to find out the value of the k, and once you find out the value of the k, that is step number, you can display the output, okay, which is the coordinate of x and y. Okay, so here you can also see that the input limits are same as which is given in the TCS NQT problem statement. The same limits are there. So here the assumption is prime number. In our TCS NQT mock test problem, the assumption is the series is from the Fibonacci, right? So here is the Python program. So there are two parts, two programs, small programs are there. This part, okay, find out the index. Okay, now here you can see that the input is there. So first of all, let us find out how they are calling. So this is a driver code. The input is 1113. So first of all, they are going to find out the step number by using this prime index method. Okay, so prime index will give the value of the k, and that k is passed to the spiral splicer program, okay, which is going to give the coordinates. Okay, so how the prime index will work? The prime index in this case is simple. So they have initialized two variables, count and prime, both to 0, and for the given range 2 comma this huge number, they are going to increment the value of the count. Okay, so count is equal to 0, initialize here, and this particular case find out whether prime number or not, because I modulo j is equal to 0. And in this case, once you get the prime number, okay, what you are going to do, you are going to increment the count value by 1. Okay, right? So this count is basically for, so you know that prime number is a number which is divisible by that number and 1 only, right? So आपको अगर count equal to 1 मिलेगा, इसका मतलब क्या है कि वो जो number आपको मिला है, that is the prime number, because count equal to 1 in that case, right? That number is only divisible by 1. So in that case, you are going to increase this prime c value by 1. Okay, so basically जो prime c होगा, that will be your index. Okay, जो आपका prime c है, that will be your index. And here you are going to check whether your input is equal to I. तो जो आपका input दिया है आपने, if that is equal to I, then you have got the index, particular index. So in that case, you have initialized, so input is equal to prime c, and then here finally you are breaking out of the loop, and then you are returning your index here. Okay, so basically this program basically gives you the step number. Okay, so the meaning is that if you provide the prime number 19, okay, so this prime index will give you the value as 8, which is the step number for that particular prime number, right? So once you get that, the next part is right. Once you get that, the next part is writing the code for this getting the index, right? So spiral splicer is the name, and here you are providing the input, and in this case batch size tracker, so step count 1. So step count 1 का मतलब क्या है? ये जो आपने टेबल किया है यहाँ पे, so जो step count है, so step count will belong to this one, okay, number. ये जो number आपको दिख रहा है ना, that is the step count. So 1, 2, 3 and so on. So step count is initialized to 1. Then we know that for the first case, तो prime number equal to 2 उसके लिए तो 0 0 आएगा, उसके लिए कुछ problem नहीं है. We have to go for the next batch. For the next batch, we know that the batch size is 2, and for the next batch it is going to increment by 2, okay, and so on. So that is why it is initialized to 2, and then this adder is initialized to 1, because either we are going to add 1 or we are going to decrease 1 for x and y. Then here this x and y are initialized to 0, and then for n in range n comma 2 comma input plus 1. So what we are going to do in this case, we know that for half of the case the x is going to be incremented by 1, okay, or it is going to decremented by 1. So in this case, if step count is less than or equal to 0.5 step limit, so in this case we are going to add the value as 1. So x जो है आपका coordinate, that will be added with the value as 1. So I'm talking about this particular case. Okay, now in this case you can see that for this part, right, for this part this x should be incremented by 1, and for the next part this y should be the x should be as it is and the y should be incremented by 1. The same thing is coded here, right? For the half of the case the x is increased by 1, and for the half of the case y is increased by 1, and whenever the step count is equal to step limit, which is the case here, right? यहाँ पे आप देख सकते हो कि step count is equal to, so this is your 1, this is your 2, right? And this step count is equal to what? This is equal to your step limit, which is equal to 2. इसका मतलब क्या है कि आपका ये बैच खत्म हो गया. Once your batch is खत्म, then you have to reverse the operation, right? So for that purpose, so in this case what they have done, they have changed the sign here. So adder is equal to adder multiplied by -1 whenever the step count is equal to step limit, and then we have to update the step limit now, because for the next batch the number of elements will be increased by 2. So step limit is equal to step limit plus 2 is done here, and then once again for these all 4, okay, we have to reset now our step count. So step count is equal to 0, right? So here you can see for the next batch we know that there are 4 elements, right? ये कितने एलिमेंट है आपके? 4 एलिमेंट्स है. तो आपका स्टेप काउंट यहाँ पे है, which is your step count, which is 0, 1, 2 and 3, right? For half of this part x is decreased by 1, and for half of this y is decreased by 1, right? The same thing is done here in this code, right? Now here you can see that and once this is done, the step count is increased by 1, and then you print the values of x and y, okay? And so let me just give the demo for this one. This is the same program which I have discussed. So reference also I have given here, okay? But this is for the prime number. You can easily modify it for the Fibonacci number. But here you can see that in the program, in the main method, I had taken input equal to 31, right? And here we are going to get the index for that. And for 31, okay, let me just change here. Okay, so let me take 19 here. Okay, let my prime number is equal to 19. So we know that for 19, the step number should be 8, and the coordinates in this case should be 0 and -1, right? So here you can see that the step, that is k, is equal to 8 in this case, and the coordinates are 0 and -1, right? This thing you can observe here. So let me give another input here. So let me give 11. Okay, so for 11, we know that for prime number 11, the step number is 5. And for this case, the coordinates are -1 and 1. So let me just check. So 11. Right here, you can see that the step count number in this case is 5, and the coordinates in this case are -1 and 1. Okay. Now, this similar question. So, in the only difference in the given mock test problem was that instead of prime numbers, they have arranged here the Fibonacci number. So, if you want, I have collected the solutions for this. I had created one PDF for this one for this session, and in this case, I have given the problem and its